we're going to kind of follow a similar, this is going to go a little faster than the other one, and the tools are a little bit better. They don't require as much memory and as much compute power as the other tools did. Hopefully you've downloaded a couple of the tools, Brim or Wireshark, according to the instructions from the lab. Hopefully you did. If not, those are easy to download. Those are open source. You can go and download them on your own computer. They're really fun to play with. Okay, so let's talk a little bit about network forensics before we do the lab again in a similar fashion that we did the last one. So just so you guys know, the last lab, typically, companies have dedicated like high performance computers with tons of memory, lots of GPUs to look at a lot of these forensic files. So what you guys saw was kind of like a minimum configuration that I could set up with the 8 gig of RAM, right? To be able to look at a very simple digital forensic file that you guys saw. But typically you would have pretty much dedicated servers to doing this. So you'll be much faster. You wouldn't see all the problems that we had before. So turning a little bit, so we start this forensics. We're now going to look a little bit about, we're going to talk a little bit about network forensics. We're not going to get into, there's two other topics that are really relevant to this. One of them is the registry forensics, and the other one is memory forensics, like non-volatile information. We just don't have time to do that. But I hope that by looking at this and network forensics, you guys at least got an idea of what digital forensics is all about, right? And I think you guys are getting the picture of what this is all about now. Here's an example of a typical attack plan. We stole this from a company in New Zealand because it did a really nice job at exemplifying the attack path, right? So initial access to a system can either occur through email, a malicious document, and which contains malware. This makes its way to command and control. We'll talk about that in a second. You can also do exploiting a vulnerability, password guessing, or phishing. Basically, what you're doing is you're obtaining valid credentials. This is all of these activities are going to be accessible through internet exposed services. And again, eventually allow you to gain command and control of the system that you're trying to attack, right? You're going to be able to get into that particular system. What are the things that you want to do once you have command and control? You're either going to do privilege escalation. You're going to give yourself maybe super user powers. You're going to add editing capabilities to something that you want to do. And you can potentially also do lateral movement, meaning I'm going to have those credentials. I'm going to use those credentials in another system inside that particular network, since I already have access to the network, the corporate network. So all sorts of things that you can do that are lateral movement. And then the last phase, right, is basically what is the impact on the target? What was the goal, right, of the attacker? And they're either going to do data exfiltration, they're stealing information from that organization. They're going to destroy backups, right? They're going to encrypt data, right? If you're doing ransomware attacks, there's lots of things that you're going to do once you gain access. But at a very high level, these are kind of the different stages that you go through when you're doing an attack. Okay. All right. I had a whole bunch of slides here because I was expecting again some non-STEM folks to be here regarding. I'm assuming most of you have taken some kind of networking class. I don't know if it's required as an undergrad, but it should be. And so I'm not going to get into all the details of networking. I'm not going to show you how to subnet and how to do all those things. That's for you guys to figure out. But right, networking basics, right? There's lots of different protocols that are being used. Some of them are stateful, some of them are stateless, depending on the type of message. There's also different things associated with network basics. At a very, very high level, right? The OSI model is something that hopefully you have all seen at one point or another, right? At the wire level, right, you have the physical connection, the fiber, the copper, whatever, the connection. And then as you move up the OSI layers, this is when you start building on what's being transferred between a recipient and a client, right? So you have bits that are going across the wire. I always like to think of this as when you're going up, you're adding things on both ends of the protocol, right? And so you're adding both information at both ends. And when that packet gets received by the client is removing those ends until it gets to the information that it cares about, right? So this is just the traditional set of layers of the OSI model. We also need to know a little bit about encryption, a little bit about compression, and what happens when things are going across the wire. Okay. A little bit of a TCP UDP refresher. These are two of the most common protocols that are used, right? UDP, the user datagram protocol, stateless. We don't care about the order in which things go. Sometimes packets are dropped, right? Again, I'm not going to go into all the details of TCP. TCP, right? Stateful. Some of the examples that use TCP, HTTP, the Simple Mail Transfer Protocol, DNS, the Domain Name Server System, right? These are examples of systems that use TCP/IP. Okay, so these are the two most common protocols that you're going to see in networking. Network forensics is hard. It's not easy. There's a lot of information that you guys are going to capture, and you're going to have lots of techniques and software and hardware that's available to capture information, all those pickups. But making sense of this, especially when you have streaming data these days, is extremely difficult. It requires a lot of storage. Things that we care about: encryption, compression, volume of the data, amount of noise. I put encryption again here because it's important. All right, some protocol definitions. If you want to know more about a protocol, you can typically go to the engineering task force and look for some of the RFCs, the request for comments. And if you don't have anything else to do on a Sunday, try to read a standard, whether it's a security standard, a NIST standard, or an internet protocol standard. I challenge you to get past the second page. Some of the key RFCs for networking, 1918 for private networking, 2616, HTTP 1.1, HTTP version 2 is 7540. So there's a whole bunch of different standards that are out there. If you're going to become an expert in one of those areas, if you're going to be a networking specialist, of course, you're going to have to become familiar with some of those particular standards. Okay. All right. I'm not going to go into how all of this works. Okay. Again, I was going to spend like a half an hour on this, but given that you're all computer scientists, there's great tutorials on YouTube for how does IPv6 work? How does IPv4 work? How does the domain name system work? Right? So I'm not going to go into that. I don't know. Was it mine? Okay. All right. IP addresses, right? IPv4 is still one of the most common ones that we use, and you saw that in the editor's files that we were playing. And this is just how they're organized. And if you want to know exactly how each of the hex digits works, and how you organize this, and how you go through a subnet and masks and all those things work, then again, that's part of a networking class. So I'm not going to go through those over here. There's also different annotations that are out there, and you're going to see things that allow you to subnet things and how you do that. How do you segment all of these IP networks, right? And so you're going to see a lot of that on your videos. It's actually pretty simple. If you've never seen these notations before, it looks complex. It's not. Once you play a couple of YouTube 5-minute videos, you're going to know exactly how these things work. It's actually quite simple. This is just shorthand notation to do this. Okay, and I'm not going to spend time on this. There are some known IP addresses that you're going to get familiar with. One of the most common ones is 127.0.0.1. Hopefully, you guys have seen the T-shirt that says there's no place like 127.0.0.1, right? So, all right. So, if you don't have that T-shirt, go to geeks.com and get that T-shirt. All right. So, normal day in network life. Okay, you type some URL, a domain, you enter a DNS request for that domain.com goes out. DNS is basically a protocol. It's like the yellow pages. Hey, what's the real address for this name? And then you get the IP address for that particular name, and now you know how to go to that particular address, right? That's all it is. You get a response with an IP address. Then you do an HTTP GET request for a domain. You get a 200. Things went really well. I found the information that I wanted on that web page. And I'm happy. Whatever it is that I was doing on the internet works. Okay, that's a typical day when everything goes well. There's a ton of stuff that's hidden here, right? But that's typically what you're doing. There's different capturing network hardware out there. We're going to go through the slides first, and then we're going to go through the lab in a second. But a lot of these, I have one student working on this in my lab, and he has exactly one of these little boxes here. And we have that box connected to Wireshark, and so he can see all the traffic that's going in and out of that particular box. We also have it connected to an oscilloscope, and so you can actually see the amount of voltage that's being generated. So it's kind of cool to look at that as well. All right. So you can capture a lot of these things. You can configure them in many different ways to capture certain amounts of information and traffic. And so I'm not going to get into the hardware either. Some of the pros, right? You can capture anything and everything that's going across the wire. And that includes non-standard protocols and all sorts of things like that. So it's really cool to look at that. The cons is typically, as I mentioned earlier, the biggest con is that you really need a lot of disk to handle a lot of this stuff. Okay. And so typically when we capture something, when we're playing around with some of these captures, we really have toy examples where we're just capturing something really small in our lab because we care, or we have a dedicated machine that's sending something specific, and we're not capturing all the internet traffic that's going across because we just can't do that. Okay. So I think we talked about that already. We also talked about this network metadata capture and some of the core network forensic goals. We want to understand the nature of the communication. So who is the communication about, right? Who's in that communication? What's it about, right? With whom? Who's the source? Who's the destination? These are the things that as an investigator, excuse me, that as an investigator, these are the things that you care about. Is that you already know the name of the person, you know the machine, because you did this with the other software. Who are they communicating with? And then you bookend the investigation, a timeline, and you also know something about some of the different protocols that are out there. So you want to find out, is this person using the web to do something? Okay, then I want to focus on HTTP. So these are the types of things that you want to look at. You want to look at key events at the network layer. Where are those things logged? So we're going to look at all those things. What are some of the common protocols that you're going to hear about? The domain name system. Okay, there's the port. It's always kind of broken, sure. Basically, it's your yellow pages. You're mapping names to IP addresses. That's all it does, right? There's some DNS servers. Most places have a DNS servers, and the DNS servers themselves communicate with each other so that they exchange information. And it's basically just the yellow pages. Okay, the DNS query is basically, okay, here's the DNS name. What's the IP? And you can also do a reverse. Here's an IP. Okay, what's the DNS name associated with IP? And use a reverse protocol for doing things like that. And then you get a DNS response. There's some caching involved, especially for a lot of the machines that you access constantly. Mail typically uses SMTP or IMAP. You probably have heard these things before when you're configuring either your phone or you're configuring your mailer, whatever mailer you're using, your machine. You're going to say what type of protocol you're using with a lot of these things. And so in one way or another, you configure these protocols in your systems and you stop when things work, right? Which is what most people do. Hey, that one works. Just leave it like that. Leave it alone, right? And so here's some of the common protocols for mail. For the web, HTTP, right? Here's your HTTP request. You have different types of requests with HTTP, right? Get, post, put. You guys, many of you have probably used curl to make requests that on the network, and they'll use these protocols. Here's some responses. We were talking about this. An HTTP response code of 200 is good, 300 is a redirect, 400 is an error, and 5xx is a server error, right? So if many of us are subject to the 404 all the time, right? So you guys have seen that on your web browser a lot of times. And so here's some of the basics on HTTP. Okay, so let's do a little bit. So that was kind of really fast networking introduction. Again, this is not a class of networks, and so I'm not going to get into any of those technologies. So let's look at network forensics. So network layers are implemented by different components. We've seen this, right? So there's different components associated with all these different layers. And so when we're doing digital forensics, we're going to focus on one or other layers, and we need to be cognizant of which protocol we're actually looking at and playing with. A lot of times, you're not going to see TCP/IP on a lot of the tools because a lot of those tools already assume that you have that's what's happening. And the interesting part sometimes is here in the application layer. So we're going to look at in our lab one of those examples and all the different protocols that we have available to us. Fingerprinting. This is where we use specific characteristics in the evidence, right? And this is done to identify a system or an operating system. And so there's little things that you can look for. In a protocol, for example, if you're looking at the time to live for a packet, packets have a certain time to live before they're not valid anymore. And so in Unix systems, I think the TLS is 128 hops, meaning after 128 hops to get to a destination, it's just going to get dropped because you couldn't find it. Windows, I believe, 64. And so then it gets dropped. So you look at things like time to live. And so there's characteristics associated with a lot of these protocols. And as you do network forensics, you're going to be more and more familiar with a lot of these different characteristics. And so a lot of times, by just looking at the packets, you can identify which operating systems are talking to each other. So that's really cool, because if you know what to look for, you're going to say, oh, there's a Windows machine, try to connect with a Unix machine, whatever, right? And so that helps you a little bit. Again, I was talking about the time to live. There's a certain maximum lifetime associated with each of these packets. And so you look for those things in the content of the information that goes across the wire. And so here you have some of the characteristics, right, for a Windows machine. Is there a question on the virtual? No, okay. We're going to look at some of the events that are in the tool that we're going to play with. And we're going to see some really easy to detect patterns. And so when you see something like this clearly tells me that we have a Microsoft Windows version 10 operating system doing something, right? And so you're going to see some of these things that are pretty easy to detect. There's going to be other protocols that are not as relevant today, and they're not as used that much. Anybody remember DCE? Anybody ever use DCE here? I don't think anybody ever did. DCE is the distributed computing environment, which was one of the original environments that used networking, client-server networking. It was developed by a company named Apollo. Does anybody know what Apollo was? Apollo Computers was eventually acquired by HP. Again, that was back in late 1980s. We're out of Massachusetts. And then here you have Linux, right? Some interesting information about Linux, right? And these are, again, just characteristics that you look for in packets to help you fingerprint something. Here's other fingerprinting for applications, right? At that level, there's certain things that you look for. So if you see domain names like this tells me it's Chrome. It's simple. If you see something like this tells me that it's probably Firefox that's communicating. With Office, you're going to see a lot of, not just next rules, but you're going to see a lot of things like officeapps.light.com. You're going to see a lot of those cookie crumbs left behind. There's a lot of macros that try to be executed via, Word has macros, Excel has macros, and things like that. And so you can look at different types of applications whenever you see Microsoft. trying to be executed across the web interfaces for a lot of these Office tools. If they're trying to execute macros and you have them enabled, that's a clue that somebody's trying to do something as well. Okay? So there's a number of different fingerprints that are out there. So the tools that we're going to use for this lab, there's this tool called Brim that you guys have installed. And basically what we're going to input into that is a PCAP, right? And has anybody ever used Brim before here? Okay, so one person has used Brim. So Brim, think of Brim as there were these researchers that started looking at lots of different data formats. And what are the most prominent data formats out there right now? JSON, XML, right? These are all the data formats that you think about. So what these researchers decided to do was, in the context of doing data analysis, they were studying data lakes. A data lake, think of a data lake, and you may have heard this. This was maybe one of those words that was, relevant for a little while and kind of stopped being one of the in vogue words. But a data lake is basically a repository of tons of information. But when you have information that's coming from multiple sources, a data lake can contain JSON, XML information, it can contain CSV files. There's a lot of information that forms a data lake. In order for us to make sense of that information, they came out with a new technique to organize that information, that data. So if you're ever interested in understanding how those data lakes or that information is stored, okay, Brim uses that technique to store what are called Z files and Z information. And it's a really hyper JSON type file that embeds typing information inside the data. So it's really cool. It's outside of the context of what we're doing here, but what you're going to see is you're going to see Brim running, and you're going to see all that information. The reason you can search it is because they've stored it in this new format that allows for data lakes to be created from multiple sources of information. It's really cool technology that was done by a group of independent individuals, and it's now become pretty mainstream. All right, so we're going to look at some of the traffic analysis in Brim. Brim is going to look at specifically two tools, and it looks at Zeek is one of the tools that's out there for monitoring information. These are, think of intrusion detection systems or host detection system, and they store information, monitoring information in a certain way. And there's another one called Izurieta, and that's also used a lot in the communities. And so what they do in Brim is they take all the log files from both these tools, and they kind of merge them together in this new format that allows us to search for relevant information when we're doing network forensics, okay? If you've ever used Zeek or Grow, Brim would be something that would become natural for you guys to actually use. So Grow, now called Zeek, okay, produces logs, and basically the logs contain protocol-based information, web traffic, network flow information, and there are things that are called weird, and you're going to see that data that is called tagged weird. These are things that Zeek thinks is weird information. It just can't figure it out, right? So it'll put it out there. So we're going to see this as well. And there's also files that are generated from the traffic. So how are we going to work with this thing? Okay. If you guys want, you can start Brim on your computer now. Just start the tool. Okay. Hopefully you guys have it started. And the first thing that I want you guys to do is when you go to in here, you're gonna have, I already did this, but it's gonna be like a dotted line with an empty space in the middle. Drag and drop that PCAP Z file that you guys downloaded, and just drag and drop it in there. And it'll take a few seconds, and it's gonna create this data lake of information for you. Has anybody done that already, or yeah? Okay. What's that? You can do that too, but you can throw it on the Brim. On Brim, yeah. You guys can just drag and drop that into Brim. You guys can do that? Okay, thumbs up, everybody, or yeah, good. Yeah, okay. Not yet. Not yet. Okay, we'll wait a couple of minutes. Yep, okay. Are we good to move on, or anybody's still working on it? Back to, okay. All right, guys. So how do you work with Brim? Once you drop that pcap file, and of course pcap files can be significantly larger and you can drop multiples of them. What's cool about the format in which this tool was developed is that it allows you to search for information and create like query strings with multiple formats. So it's kind of a mixture between Unix command line format using piping and things like that. But it also has kind of an SQL-like-ish kind of query. And so you can mix and match all of these things together. Unless you want to become super, an expert in using these kind of searching techniques. I mean, it's cool, but I don't have the time to do it. There are some basic things that you can do. You can search for basic things, and I'm going to show you how to search for basic things here. You can summarize things by piping your results through a count. There are multiple functions out there that allow you to do different things, like you can sort, right? You can do all sorts of things. You can drill down, you can pivot into the logs if the logs are available. You can actually pivot to the logs. So there's lots of things that you can do, and that's only possible because of the way they store the information using these data lakes. So it's really cool technology. So it uses the piping. Here's an example where you're selecting anything. This is a column that you're going to see in Brim. I'm only looking for DNS records, protocols, and I'm going to count them, and then by query, and then I can also sort them in reverse order, for example, or numerically. You can do all sorts of things with this. So anyway, there's lots of things that you can do, lots of features that you can use to play with Brim. Once you play with it for a little while, it's actually there isn't a ton there, so it's actually easy to master this particular tool. Okay, you can drill into any of these things. You're going to have all sorts of different ways to visualize this information. So how do we build a traffic summary? What we're going to do is we want to know who's talking, the source and the destination IP, and we're going to see how we do that. And then what is the nature of the communication? What is this for? And so one of the things that we can do is we use Brim to find out a little bit about who's doing this. And then one of the things that we can do is Brim has a little shark fin component at the top. And so if you install Wireshark on your machine, it will automatically jump to Wireshark so that we can continue to do investigation using Wireshark. Okay. All right. So here's an example of traffic summary. Right? We have clients, local DNS server. We're going to have queries. We're going to have non-standard activity that's observed. There's a number of things that we're going to do to look at to do our investigation. SMTP. Okay, you're going to have traffic between clients. You're going to have a list of email servers that we can look at. You can have all sorts of standard and non-standard traffic. You're going to find out information about ports, protocols, all of this type of information depending on the protocol that we're looking at. So is it interesting? Is it good? Is it bad? Okay. So we can do signature-based matches. Okay, Suricata, the tool that Brim also uses, these are typically alerts that come from that tool. It looks at certain signatures that it knows about. Okay, and Brim is going to help you look at those. There's also outlier analysis. Okay, you can look anytime that you see the same IP address pop up lots of times, right? Whether you see it in log files, whether you're seeing it in Wireshark, whether you're seeing it in any tool, you know that somebody's trying to do something, they're trying to address something, trying to look for something, right? And that's pretty normal. We actually use one of these tools. Actually, this is in my site company. One of the things that we noticed is we use Stripe. As you guys know what Stripe is? It's a checkout tool that is used to pay for a credit card. For credit cards, exactly. And so we had set up a Stripe account for people to check out and buy our items. And so some of the items are worth like, 99 cents. And so what happens is some company in the Ukraine, they figured out that, this is an easy place to target. And what they did is they tried a whole bunch of credit card numbers. They steal credit card numbers and they generate credit card numbers at random. And they try to buy these 99-cent items, right? And every now and then they're successful. And so when they're successful, they have a valid credit card that they can sell on the dark net. And so our site was being used as a testing site for all these people that they were testing credit cards, and they were using our site because we didn't have it secured properly, right? And so they were using our website, our checkout system, and they were buying like 99-cent books because the 1 out of 100 credit card numbers that they generated, right? Oh, this is a valid credit card. We can sell this in the dark web, right? And so what do? We found out, that somebody was using this by looking at P-Connect. So there was the same request from the same IP address, and you can find out where the IP address are coming from, and it's using the Ukraine. And we're like, somebody's using our website to buy lots of 99-cent books. And there's tons of failed purchases. And that's because they were testing credit cards, right? So what do? We set up a CAPTCHA to make sure that, we offset a lot of those bots, right? And so that helped us do that. But you only learn by doing. In fact, we had no idea until you actually start doing, right? So anyway, when you see something that's repetitive, right, that's when it's also something that you should be aware of, okay? So this is the logo that you're going to see at the top. We're going to start playing in a second here. This is how you go to Wireshark, okay? And we're going to follow Wireshark for a couple of things. We can follow stream extraction from Wireshark, so we can follow the entire conversation between two machines in Wireshark. So we're going to look at that. And then we're also going to see if we can do some decoding. And you guys saw that we can do decoding using CyberChef already. So we can do that as well. All right, so let's, I'm going to end that here. Let's go to, here I am. So I have, make this a little bit bigger. Okay. So I loaded the pickup file. I loaded it twice. It's not a big deal. Okay. And this is kind of what you guys are going to see. There's two ways to look at this. This is the pretty way. Okay, what you see on the left-hand side. So if I click on that, that's the pretty way, the pretty print version of it. But if I look at the ... here, that prints it in the actual record format in which it was found from those tools. So I can expand one of those. I can look at a record, right? And this says, this record is a capture loss. This is a timestamp, a delta, how long we occurred. This came from Zik. Here's the number of acknowledgement. There's 0% loss. So this information that came from one of these tools, right? And so if you know a little bit about that tool, you're going to find more information about that. Let's look at another one. Here's an HTTP record, right? So this has a little more information. Okay, here you have all sorts of things, UIDs. You have another record embedded within a record. So I can also follow that record that's embedded. This has an originating IP address and a destination and a response IP address, right? And so you can actually go on Google and type what's orig underscore age and response underscore age, and you're going to get a description of what these things mean. Right? And it'll probably tell you these are associated with Zeek or some of these tools. Okay, but the pretty way of looking at the records is good as an initial perusing through what you're looking for. And then once you start actually trying to investigate something, you want to actually click on the record to start seeing what information is there on that particular record. Okay, so this is BRIM. It's basically a whole bunch of records listed for you in here. So what's one of the things that I want to do? Let's focus first. What if I just wanted to look at DNS? Here on the bottom left, you have a history of the commands that you run. So you're going to have a history of all the commands that you run here, so you can recall them. So you would type them in this window up here, in this little box. So if I type this, path equals DNS, right? Path equals DNS. It just gives me all the DNS records that it found in that pickup that I have. You guessed it. If you say HTTP instead of DNS, you're just going to get the HTTP files or records. If you just say something else, that's all you're going to get. If I want to go and look at all the activity overview, I always start by looking at the activity overview. Okay, and here, this one's hard to read, by the way, the yellow and white, and that's just Kerberos. Okay, Kerberos is security. Okay, that's all it is. But in here, it tells me that I have one record for this, I have 4 records for that, I have 5 records for that, right? And you're starting to see all the different records that this tool is showing you from the data lake of all the records it collected from the tools Bro or Zeek and Suricata that will run that system to capture that pickup. Okay. So now, basically what you have is evidence here, right? But it's network evidence from the pickup files, okay? As opposed to a computer image that we captured before. Now we have all the pickup file and the information captured. Okay. All right. So what's the first? So this is kind of like what the tool is all about. You can also look in here for different things, HTTP requests, and you can play with this. This is fairly fast, and you can mess around with this as much as you want. So let's go through the lab really quickly. Okay. So the first thing that we asked in the lab was, what is the hash of the pickup file? I'm not going to go through that again. This is that process of finding information about what you have. You can use the get hash value from PowerShell just to do it on that particular pickup file. Okay, so you can do that. That's pretty easy to do. The next question that I ask is, what protocols are used in the pickup file? And what you would do is we just go to the activity overview, and this has a list of things in here. So which of these things do you guys think are protocols? So this was one of the questions that I have for my students when we're doing the assignments, right? And basically it requires you to go on Google and try to do a little bit of research. Out of all these things that you see in here, which one is a protocol and which one is not a protocol? Right? So you're just learning, right? So DNS, SSL, HTTP, X509, SMTP, ERPC, Kerberos, KRB5, NTLM. Anything else in that protocol? Did I get one wrong? I'm happy to be corrected anytime. So yes.
X509, the TLS.
This TLS uses because X509 is just for certificates.
Yeah.
And so
it's not really a network.
Yeah, so I guess some of them are gray area. Yeah, fair enough. Okay. But anyway, you guys see what's over here, all right? What was the next question? It says, what is the IP address of the workstation, the potential victim? Okay. So one of the things that you can do is if we go to just DNS, so I'm going to recall this, or you can type it on your own. If you go to DNS, you're going to look at the originating IP address, and you're going to see it here in this column where my mouse is and hovering over it there, right? And you're going to see a ton of, if you scroll down this, you're going to see lots and lots and lots, and it seems like almost every originating address is going to be that. So this is the IP, okay, of the original workstation. And the response, this one here, is probably going to be the DNS server in that network that is going to look for things that you're trying to request information about, right? So that's the response. So 10.3.1.101 is talking to the DNS server, 10.3.1.3, and it's returning, hey, here's the IP address you want to go and really talk to, or something like that. So it's talking to the yellow pages, right? So this is the IP address of your original system, and this is the IP address, the response that you're getting is probably from the DNS server. So now you're kind of establishing some of the communication. Okay, what's going on? The machine, and this makes sense, right? Your machine, in order to find the IP address of someone else, has to go to the DNS server first before it gets that information that it needs. All right. So what is the next question? Was the IP address of the DNS server? And we just saw that that one is this one over here. Okay. Now, if you had multiple addresses that you see in the response, right, you probably have to do a little bit more digging to find out which one's the real DNS server in my organization or not. Okay, it's never going to be that simple all the time. Okay. All right. Let's see. A lot of the DNS logs that you see here, all of this stuff is really captured from the Zeek tool that's running underneath. And so Brim read all of those log files and he put them in that format. So if I can look at one of this in record form, right? Here's the information, and here's the originating address, here's the port that it's being used, and here's the name server that's responding on port 53. Okay, so there it is, all that information. All right. The next question you're not going to have to do, if this were an assignment, you would have to do it, is to write a brief summary of each of the protocols that appears in the PCAP, right? So you already know about HTTP, right? Is there any, I think one of the questions that I have is, is there any malicious activity that you think is associated with a particular protocol? So I'm going to go back here. So let's say, for example, let's just look at the HTTP requests. Okay, so if I just look at the HTTP requests, I'm going to find a whole bunch of information here. And this is, you can see that I saved a lot of these queries, right? And you can see the queries on the top here, right? And basically it's the path equals HTTP. And then I cut a whole bunch of the columns that I wanted. You can put all the columns because it returns a lot more information, right? And so you can play with this very unit style as to what you want to display. Okay. And what you're seeing here is there any evidence of something going on here? So what's the first thing that I'm going to do? The first thing that I'm going to do is I'm going to Google. It looks like there's some host here that's interesting, that there's a lot of communication with. And then there seems to be a library that's being used a lot, right? And this library is a jQuery 321 main.js library. Okay, so these are two things that immediately jump out at you when you start looking at the HTTP communication. And you would do this with all the protocols to see if there's anything that you think is malware-like. And so here we find out, okay, you know that there's a couple of things. Let's go and Google some of these things and find out if there's anything in there, if there's any activity. And so one of the things that you're going to find out is that this domain name is associated with a particular type of attack. Okay, so we're going to look at a little bit more about, how is that attack related to this particular system. So it's interesting to see that. The other ones didn't really yield a lot of information regarding any type of attack. So the next question was, what is the operating system of the potential victim? Okay, so one of the things that you can do in here, we can look at unique DNS queries. So here I have a command, path equals DNS, just sorting all of those. And just when you look at the DNS queries, remember DNS queries is this IP address asking the name server for information. That's all we're doing, right? We're asking for information. So I'm going to look at the DNS queries, and guess what? The second entry that I see from the top, okay, there are 6 queries that say v10 events data.microsoft.com. So that immediately tells me it's likely that this is a Windows system. There are more ways than one to do this. And the better you get, the more logs that you start looking at, you're going to identify, oh, there's another clue that this is a Windows system. Here's a clue that this is a Windows system that's sending these things. Okay, so there's an example that tells me that. So did an attacker gain access to the system? Okay, so what's one of the things that we can do in here? You can start by reviewing all the Izurieta alerts by category. Let's see if we have that in here. Let's see if we have the Izurieta. I may not have placed the alerts. Oh, there we are, by category. And here's one Izurieta alert that says potential corporate privacy violation. Okay. There's also malware command and control activity detected. Remember, BRIM is a tool that is a data lake, and so it's looking at the output log files of some of these other tools. And so by me going over here and looking at the Izurieta alerts, Izurieta is a tool. Okay, that's one of the first things that I would look at. What is that tool actually telling me? If you're already doing the work for me, are you finding anything interesting? And it found some malware command and control activities that it already detected. So here's something that, here's a tool that's telling me that there's potentially something else going on here. Okay. All right. So how did the attacker gain access to the system? When I look at, let's go back to the DNS. Let's see if I can look at one of the records. Or let's look at the HTTP. Yeah, let's look at HTTP. Okay. HTTP. Okay. When I look at the record, okay, one of the things that you're going to find quite often in here, in fact, I had another one that was even that. You look at this here, and this is a library that appears quite a bit. This jQuery 331 read.js. So if you just Google that particular query and you query malware, is there malware associated? This is one of the things that you do with Google. You can just say malware for this particular library. So if I look for malware in that particular library, you're actually going to find out that this particular library is actually associated with there's something that's called the Cobalt Strike known malware, and Cobalt Strike is associated with this particular library. Okay, so how do we know this? So this is part of the next question that we have over here. And so when did the attacker actually gain access to the system? So we're going to look at that domain name. This is KLYCMIK.com. This is the other interesting value that we found when we're looking at all these DNS queries. Okay, and so one of the things that we can do is look at this and let's open up, see if we have more information on that. There's a record. Okay, so here we have information on the host that appears to be sending or using this particular library, this jQuery 321, that we know has some that is associated with this particular malware. Okay, and so we need to take a look at this and see what's going on. And we found out that there were 265 requests. You guys remember the previous slide? There were Izurieta detected approximately 265 requests that were coming from this. And so that's one of the things that you're gonna, when you query, you can actually query KLYCMIK.com, and you're gonna find that this particular system is actually known to be associated with something called Cobalt Strike. Okay, so what are the files that are present in this particular capture? You can go to the queries over here, and you can go to file activity. So here's the file activity. Okay, and you're only going to find a couple of files in here. I'm going to put it in pretty form. Here's a couple of the files that are associated with this activity. So these are the two files that are detected in this PCAP extraction. Okay. And so let's look at that first one over here. Let's make it in this. Let's look at this one. So look at this. So we have this file appears to be a zip file, right? And it's an invoice that's somehow attached to a record. So it's probably an email attachment. One of the things that you see here is that we have both of the hash files associated with it, which is really cool because when we're looking at files, if we look at the two hash files, now you know that we can use VirusTotal. I'm going to go to VirusTotal and enter those two hash files and see if there's anything associated with this particular file. Now, VirusTotal is probably not going to give you an answer when you enter a zip file. It's going to say nothing there. Okay, there's nothing there. And so we're going to have to figure out a different way to see what's going on in the zip file attachment. So VirusTotal it'll probably say nothing found if you put any of those hash files. What is the other record or the other file that was found by this tool? We have another one, another DLL file. And in this DLL file, this is definitely something we can put in VirusTotal. And you can pick up the SHA1 or the MD5 and put that on VirusTotal. And you're going to see that this is a Trojan, a known Trojan malware that exists out there. Okay, so how do we deal with that particular file now that has that's a zip file? So let's do this. Let's go to here. We're going to, this is the zip file. So we're going to highlight that and let's go to Wireshark. Okay. Let's see if we find anything using Wireshark that we want to investigate a little bit further. So basically we found the file through Brim. We found out that the hash doesn't tell us anything from VirusTotal. So we need to find a different way to do this. So I'm just going to click, if you have Wireshark installed, you can just click on the little shark, and hopefully this brings up Wireshark. Yep, so it's loading Wireshark for us to take a look at. Okay, so now you have Wireshark, which is giving you the source, the destination, the protocol that's being used, information about what's going on. So this is all the communications, okay, that happens. This is what's going actually across the wire. I'm not going to do a full tutorial on Wireshark, but this is what's giving you a lot more detailed information about what's going across the wire. One of the easiest things to do is you want to click on the very first item that you see here when communication begins, and you can right-click on this, and you can just say, follow the stream, follow that communication. What's going on here, right? So if I follow that TCP string, and I follow that communication, look what comes up, right? I came up with, it appears to be some kind of email message that was sent from this person. It was sent to Simon Chevalier at pnc.ca. I honestly haven't Googled if that's a real person. Might be interesting. It's a real file, by the way. So don't unzip them on your computer and start playing with the malware. Yeah, if you want to know. But let's look at Simon Chevalier and see if it's a real person. It probably is, right? It's probably a banker or something somewhere in Canada, right? All right. You're all wearing white hats here, okay? So what else is here? We find out that we have an email message. Is there anything in the email message here? So you can scroll down, and guess what? There's an email message here, and there's the zip file that we found that we couldn't use VirusTotal for, but we found the zip file. It's xzip compressed, so we know that's compressed to xzip. There's the name. It's encoding in base 64. And you have a whole bunch of information here. So what tool would we use? We'll probably go and use CyberChef to start playing with what's in there in that particular email, right? And so now we can start playing a little bit more all we did was use Wireshark to help us follow the TCP stream, the communication between the two machines. We found the email message that was going across the wire. We can open the message because we have Wireshark that allows us to follow that particular communication, and it put together what we found. And now we have CyberChef, another thing that we can use to see if we can decode what was inside that particular message. So that's really cool. So now you guys can see how doing this digital forensics is about using a whole bunch of different tools to help you get at what you're trying to get, right? We're making progress every time until we get to the point where we want to find out what's going on. I'm not going to go through CyberChef and trying to decipher all this stuff in here, okay? But I think you guys get the idea on what's going on. So, so that's you can find a lot of information using Wireshark and using this tool. I'm not going to go through all the different details that are here because we just don't have time to be able to do that, and we're already at a little bit late. And so to finish this up, you guys, the rest of the slides just talk about exactly what we were doing here, following the TCP/IP stream, actually getting to the email, right? And seeing what was there. You can decode it, go to CyberChef and actually decode the message if you want to. And then you can also look at different file activities as we saw here, et cetera, and then put all these things into VirusTotal to see, if you have a zip file, VirusTotal is not likely to give you anything. Okay, so that's about it. So I know it's 4:45 and this probably went a little longer than you guys expected. It's kind of a whirlwind because there's so much here, and digital forensics is just it's a field that's you can really become an operation person, meaning an operations person. You're going to be really savvy about every tool and the nuances of every tool, and you're going to get really good at learning what systems to look for, what are your cheat sheet shortcuts. You're going to get really good at doing that. It's a tedious job. You're going to be sitting in a room, and this is from experience from friends that are doing this, where they have people sitting in a room all day. This is what they do. They're looking for a needle in a haystack. That's what they do. There's the engineering side of digital forensics, which is actually building some of these tools, right? You're a software engineer that's actually working in software development, building better tools. And then there's the academic side, which is you're doing experiments and we do using scientific method or whatever. We do foundational research. Some of the key things that come out of this, clearly you can use AI, machine learning to find, what are the trends? What are the types of design patterns that we should be looking for inside the data? What are the shortcuts that we can do that are known common attacks or threats that we can be using and maybe adding them to those tools and communicating with the engineers that are operationalizing this technology and talking to the operations people to be able to do that, right? So you use kind of a SecDevOps approach to be able to do this life cycle of technology. So with that, that's there was another question. There's a question here. So
I was going to ask if we can get this spreadsheet.
the slides, yeah, I can do this. I'll talk to Bernie and make the PowerPoint for you guys. There's actually more material that I'm just more able to cover.
And that's why.
Yeah.
Go through this so fast.
Absolutely. And again, the point of this wasn't to make you guys experts in any of these tools, but just to give you an idea of the process of doing digital forensics. And we did it with an example on disk, and with example of very quickly an example of using network forensics to see how we can follow the traffic. We didn't cover memory forensics for non-volatile. We didn't cover registry forensics. So there's a number of things that are there, but the process is pretty similar. Okay, it's a similar process. And so hopefully with that, I turn a lot of you off in terms of becoming digital forensics experts. Because I can't imagine doing this myself every day. I think I would go nuts. This is worth than being an ATF controller or something like that. I just cannot imagine doing this. So anyway, with that, I want to conclude that. So I guess I have time to go and grab something. So see you guys tomorrow. So,